Welcome back, everyone. This is episode 2 of our Vanilla Transformer series. In this episode, we'll look at what goes in and out of the attention block and what form that data takes. Here's a simple view of a transformer. Each layer is made up of an embedding block, an attention block, and a feed-forward block. They stack multiple times. That's where the deep learning comes from. And right at the center of all of this is attention, the mechanism that lets the model focus on what truly matters. Think of attention as the place where information gets mixed, refined, and made meaningful. So, what actually flows through the attention block? The input and output are both embeddings of chunks. An embedding is just a numerical vector, a way for the model to represent data like text, images, or sound in a mathematical form. A chunk is a small part of something, maybe a word, a patch of an image, or a short slice of audio. So the attention block doesn't process raw text or pixels. It processes these embedding vectors, structured numerical representations. Let's see a simple example. If we take a sentence, "I love to code," we can break it into chunks of text. You can think of chunking as slicing content into smaller, meaningful parts, each ready to be turned into numbers the model can understand. The same principle applies to images. We can divide an image into small patches. You can think of these patches as the image's chunks, each carrying part of the visual information. Each chunk of the text, such as "I love to code," represents a meaningful piece of information. These chunks are then converted by the embedding block into numerical vectors. We call these embeddings. Each embedding now holds the meaning of its chunk in a way the model can process mathematically. Likewise, each of these patches is also turned into an embedding. So whether it's text or image, we always break the input into smaller chunks and represent them as embeddings before any further processing. Now, all embeddings, whether from text or images, live in what we call a vector space. Before attention, these embeddings are context-unaware. Each dot stands alone, scattered, with no sense of relationship or pattern. As attention processes them, their positions in this space shift, meaning their meanings become refined. The embeddings are rearranged to better reflect how they relate to one another. The output is now context-aware embeddings. Each token now understands what's around it. You can think of it like a conversation. At first, everyone talks alone, but after attention, everyone understands what others said. That's why we say, attention makes embeddings aware of their surroundings. Now that we know what attention does, let's recall what we introduced in episode 1, the 3 main types of attention in transformers: self-attention, masked self-attention, cross-attention. How do they differ? Here's the key insight. All 3 types of attention share the same goal: to produce better, context-aware embeddings. But what's different is the mechanism, how they achieve that goal. We'll dive into those mechanisms in the next video. For now, remember this: the goal stays the same, creating richer, more meaningful embeddings, but each type follows its own path to get there. Now you're ready for the next part, where we'll open up the block and see how attention actually works inside. If this video helped, leave a like, subscribe, and share it with someone learning transformers too. Thanks for watching, and I'll see you in episode 3.